The transmission system. So this is your unit 6 and session number 1. In this session, so what we're going to discuss is the whole drivetrain. Instead of just discussing the transmission, I'm going to discuss about the whole drivetrain component. So during this session, you'll be learning what is drivetrain, why transmission is necessary, operation of the transmission, manual and automatic transmission, transaxle, 5-wheel, clutch, automated manual transmission, also known as AMT, drive shaft, propeller shafts, final drive, and other parts. Yeah, if you have any questions, you can ask at the end of the class. Yes, so what is drivetrain? So we'll start from there. So the reason we call this whole section as drivetrain, so as you can see in the image, everything behind the engine that actually transmit the power or transmit the force or rotational force up to the wheels actually comes under the drivetrain, right? Comes under drivetrain as shown in this image. So everything after the engine. So that means all these light blue parts are actually comes under the actually comes under drivetrain, right? So drivetrain means the transmission. So I'm not calling this part as gearbox. I'm actually calling this as a transmission. I will give you the explanation later on. But this whole section is actually known as transmission, right? Then we have the propeller shaft. So this is actually the layout wise. This particular layout, we usually consider this actually as the front engine rear wheel drive layout. So in this case, the transmission includes the clutch or this disengagement mechanism, the transmission, or the gearbox in this case. I'll explain that again why I say transmission and again gearbox. Next, the propeller shaft, right? Propeller shaft, then it goes to the final drive and the differential. So this contains the final drive and the differential. Finally, you have the rear axle shafts, right? So these are the axle shafts. So this whole housing is actually the axle. So inside the axle, you have two shafts which are known as axle shafts, right? So that section comes under drivetrain, right? That section comes under drivetrain, but once we combine engine into this, right? Once we combine engine into this, that means if we combine engine plus drivetrain, that means engine plus drivetrain actually comes, we call that as powertrain. So once we combine the drivetrain with the gearbox, it actually comes as powertrain. Okay. So that's what actually the drivetrain does. So the purpose of the drivetrain is to actually transmit the engine power up to the wheel. So all the components here is actually designed and developed in order for smooth power transmission up to the smooth and reliably transmit the power up to the wheels. Okay, so drivetrains, there are different types of drivetrains, right? So drivetrain, actually the design of the development or the layout of the drivetrain actually depends on the purpose of the vehicle actually designed for, right? For example, a usual passenger car, right? Normal passenger car actually, the front wheels are actually driven, right? So in that case, driving the front wheel is the most suitable solution, because when you are driving the front wheel, the cabin space, the space available inside the vehicle is more, and less components, less weight, and production cost will be reduced as a result of that, right? So the front wheel drive system is available. Similarly, rear wheel drive system is available if you need more balance, and if the vehicle is traveling at a higher speed in such case, and if you are taking a bit more load in such cases, you can actually use the rear wheel drive system. And 4-wheel drive and all-wheel drive. So there's a difference between these two, right? There's a difference between these two. The main difference actually is, I think I have already discussed about this one, the four-wheel drive. The power will be transmitted up to all four wheels, right? All four wheels, right? All four wheels. Permanently, it can actually deliver power up to the front and rear wheel at your choose, when you choose it. So you have to actually select whether you have to go on four-wheel drive or you have to drive as a two-wheel drive. So that's the difference between four-wheel drive. And the all-wheel drive, in the all-wheel drive system, it's actually having a differential in the middle of here. So it can actually, the differential can decide whether the vehicle have to have four-wheel drive or front-wheel drive or all-wheel drive. Right? Sorry, all-wheel drive means four-wheel drive or front-wheel drive, or whether you have to send more power into the rear-wheel drive or something like that. So that can be decided with this all-wheel drive system, right? But it's not that simple, right? It's not that simple to actually explain. Even though I'm saying the four-wheel drive system, all time four wheels are going on, that's not exactly what happened. The reason being, because all four wheels have to have the same condition in order to actually get the same output from all four wheels, as we discussed when we are discussing in the when we discussed during the differential. I'll explain that power is not actually transmitted to all four wheels, or in two wheels, at least in axle, both wheels are not getting the same amount of power. It's actually divided, right? Divided based on whether how much of speed is going, how much of traction is having, how much of friction between the wheels. So there's so many parameters around this. So it's not easy to actually explain, but it works, right? But it actually works. So there are mechanical ways to actually so this all-wheel drive system is getting very popular now. So previously this rear-wheel drive system was very popular and understood, selected as the best layout for vehicle, but still it's actually considered as the best layout because of the steering dynamics. So when you steer it, so this rear wheel drive setup actually gives you the most control, right? Most control. Next we can actually say like all wheel drive can actually give the same amount of control. So these things are very complicated, right? Very complicated. This is actually the dynamic behavior of the vehicle. So we were discussing about the engine previously. Inside in the engine also, we just discussed about the piston going and up and down. That's all we basically discussed. But what happening inside is actually very complicated, right? The combustion process is a very complicated and difficult process to master. So once it's properly mastered, only the engine will be actually operating at very good efficiency. So similarly here, since we are actually working with four wheels, and especially since we are working with the tires and road conditions, the vehicle behavior is very difficult to actually explain just using an image like this. So right, so I'm just going to leave at that about this drive layout. You just have to understand there are different type of layouts. Each layouts are good at different applications. So I actually didn't say this four-wheel drive system is very good at actually very difficult terrains and off-road situations, but in the four-wheel drive system is very good at very hard and off-roady, like sort of like very difficult terrains. All-wheel drive system is very good if you wanted to actually travel fast on a loose surface sort of thing, like a gravel road or something like that. All-wheel drive system is very good. All-wheel drive and rear-wheel drive are like comparatively fighting in like a tarmac, sort of like a normal road. These two can actually like have similar dynamics, especially this all-wheel drive system can be designed to actually designed to have the same characteristics as a rear-wheel drive system by changing the gearing ratios between the front and rear, right? Front and rear, those sort of simple solutions even can be used. But by adding these electronic control modules, right? Electronic control modules, we discuss about the electronic control module, ECM, right? ECM that used in the engine, but there's another module, we call it as powertrain control module. So the powertrain control module is actually control everything. That includes the engine, transmission, the differentials, everything can be controlled. So these sort of arrangements are used in such vehicles, such as actually almost every vehicle nowadays actually have a PCM, but very well used. This application of this system can be very well seen in vehicles such as this. I call this vehicle this Lancer, sorry, Mitsubishi Evolutions and Subaru Impreza STIs. So those actually have very good all-wheel drive system with computer controls. It can actually send this power to any wheel that necessary. Not that all, even the Lamborghini Murciélagos, the Porsche, everything, like most of the vehicles, most of the performance vehicles use this in order to get that edge over the competition. So when it comes to these wheels and how the power transmitted and everything, there's another part we need to discuss. That's actually the traction and friction, right? Traction and friction. So this part is very important, right? Very important. The theory behind any vehicle is, right? Any vehicle is, in order to keep it controlled and stable, right? In order to keep the vehicle under control and to keep it stable, you only need to do one thing, right? You need to do one thing, right? The golden or the golden rule of a vehicle control is, whatever happens, you just need to keep your wheels touching the ground at all times, right? Touching the wheels at all time. So if you have enough contact between the wheel and the tire, tire and the road, you can stop the car, vehicle, you can accelerate it, you can turn it, you can even slide it, you can do anything, right? But if you lose that, you're going to lose the control of the vehicle. So it could be polo accident or whatever it is. If you lose the contact patch, it's so much difficult to actually gain it back. So traction and friction is the two main things that we need to discuss. So first we'll start from the friction, right? Friction, I think you all know what is friction. So friction is the surface resistance between two surfaces for the move, right? So if one surface is trying to move, similar to here, similar to shown in over here, right? The force is actually applied, the capital force, F force, is trying to actually push it to the rightward side, right? It's trying to move it to the right, but friction resistance, the resistance force from the frictional, is actually trying to stop that move, right? So that force, right, that force is actually used by us in order for us to move, right? Even when we are walking, right, we use the same phenomena, right? So in this friction, there are two areas. So this is actually this graph, I think you know this graph. So this is the force, applied force against frictional resistance, right? Frictional resistance. So here you can see up to this section, right? This section actually comes as the static friction, right? So static friction, during this part, there's no movement, right? There's no movement. At this part, there's no movement. There are no movement. But if you pass this threshold amount, right? If you pass this threshold amount, right? That means over here, if you pass this threshold movement, you can actually easily, push or pull it afterwards. The reason being, this frictional force, actually the frictional resistance force, will drop suddenly. It actually drops. So this is suddenly drop. So this is the maximum amount. So if we can keep any surface in contact for a long time around this area, right, then it will actually work very effective. So the same is applied for ourselves. So when we are actually walking, we keep the friction, right? We keep the friction between in this static friction region, right? In this static friction region, because if we pass that friction region, if we applied force beyond that, what actually going to happen is it's going to overcome this static region, and it's going to lose this frictional resistance, and we are going to slip and fall. Same thing is applied for the vehicles as well. So the traction means track means sort of like a pathway, right? Track means a pathway. So traction means the friction on a path. So when the tire is actually rotating, it actually creates a track. So the friction on that track is actually meant by the that's what actually meant by traction, right? So this frictional force actually propel this vehicle forward, right? Propel this vehicle forward. So that propel, right? That the force actually contact between the vehicle's tire and the surface is the tractive, right? That's the traction we needed, right? The same thing for us. If we lose that traction, right? If we lose that traction, when we are walking, we're going to fall over, right? We are going to fall over. So in the vehicle, you have to come back to the vehicle again. So in the vehicle, we talk about the power, right? The engine power. Engine power is not the one we actually have to be worried much. We have to worry about the torque value. So if we consider about the engine, right? So this is your this is your piston, right? Okay, that's not a piston. So traction torque means actually the tractive effort, right? Torque means sorry, this color has to change. Let's go. Force, this is the force, right? So the piston, if we use the piston again, piston force is actually acting downwards from the combustion. The force is actually acting downwards. That force, the ratio of a certain section of that force is actually acting on the connecting rod. So that force is rotating the crankshaft pin, right? This crank pin is rotated by that. So this crank, yeah. So this crank throw, right? This crank throw, the length is there, right? So there's a length here. So this crankshaft is actually rotated by this force. If this length is L, right, your torque or the active effort is actually comes as F into L, right? That force transmitted all through the drivetrain at it's delivered into the center of this wheel, right? Then it's actually applied as a force against the road, right? So when we apply it against it, there will be another force acting against the applied force that move the vehicle forward, right? So this applied torque, so this is the torque. That torque is actually delivered from this equation here, so F into L. So that force then goes to the gearbox, to the transmission, the drive shaft, and everything, and comes back to the wheel. And when the wheel is actually rotating, that this F, right, this F is again applied here in not as capital F, something like a simple F, because of the all the components there. Right? It has to go through a lot of components, so that's why it's actually simple F. So that force, right, this simple F force is going to result in generating another force, which is actually known as the tractive force, right? This tractive force, right? So if we increase this force, this simple F, in this case, the simple F is actually when it goes beyond this static region. If we increase this applied force, right, where that simple F is actually comes here, right? So when it's increase this static region, right, if it lose this point over here, then suddenly the frictional coefficient will drop. As a result of that, friction resistance will reduce, and you will not be having any tractive force afterwards. So as a result of that, your wheel will be actually spinning, but you won't be moving forward, right? You will not be moving forward. So what that means is slipping is not actually very good. We should, at all times, we should not actually slip it, right? But there are some situations that we need to keep it slipping. I'll come back to that, but you have to remember this graph very well. This is very important. The same thing applies for the ABS system. In order for the ABS system to work, the same thing is applied. So in the ABS system also, what actually ABS system does is it's try to keep the friction bit around this area over here. So if it actually goes beyond this, right, the friction is going to reduce and the heat is going to increase. As a result of them, again it's going to slip, right? Again it's going to slip. Hopefully you get what I'm saying. This is actually important. This again comes back in the suspension systems, right? So that's what actually happens in a situation like this, right? In a situation like this. So the main reason for slipping, right, if you have a vehicle slipping like this, the main reason is you don't actually have enough force acting against it. So there's no resultant force upwards, right? So as a result of that, we can't actually put enough force, we can't apply force enough force we can't apply, so no tractive force will be generated. But if we add weight into this, sorry, if we add weight, right, if we add weight, so if we add weight to this wheel, or if we put another sort of anything underneath the wheel, so at that times the surface contact patch will be gained and more force can be applied on the wheel, like more force can be applied on the wheel. As a result of that, we can actually increase the traction, right? We can actually increase the traction. So but as I told you, in some cases this is somewhat useful. So I have shown two images. So in a usual case, when we are driving in the wheel, when we are driving on the road, this is completely useless. So wheel slipping is completely useless, but seeing people seems to be thinking that's cool, or it's very good, it's looks nice and everything. It's very ineffective, right? Very ineffective, because there's no force applied, so vehicle will not actually move anywhere. So if you look at any race, right, any race, right, so race means the most efficient way of driving a vehicle. So if they are trying to drive the vehicle most efficiently, so for example, so I'm going to draw a curve like this, right? So if I ask someone to drive it on this curve, so you will drive like this, right? You will drive like that. But if I ask a racing driver, a person who is actually trained to drive on a track like this, how they drive is something like this, right? Something like this. And assume that there's another curve or corner next. Assuming there's another curve like this. So a person like that, they will be actually trying to optimize the road like this. By doing so, he is actually traveling less distance. So the distance he will be traveling is less. And the other thing is, you can see his speed. So he don't actually have to reduce the speed in order to keep this line moving. So he can actually maintain the speed, right? So this is actually known as a racing line in a racetrack. Anyway, so what I was trying to say is, so in racing applications, no one is actually doing wheel slipping or something. If it is actually doing any wheel slipping, that's very inefficient. So that's why race cars or racing drivers never do wheel slipping. But there are some instances that actually happen in some cases, like what you call that movie, Fast and Furious. Yes, in such cases as Fast and Furious. So in such cases, the winner is actually having wheel slipping and everything. So that's never going to happen. So it's just a cinematic how cinema is actually trying to show. But what I show. So as I told you earlier, this is inefficient, right? This whole thing is actually inefficient. But there are two so this is a normal application, we can actually see it, but this is inefficient. But if we go to these two images, the first one is actually showing two cars. So these two cars are actually going to get ready for a drag race. So drag race is a straight line race that accelerate for the highest speed. So in such cases, before the race, the drivers actually do this wheel spinning. We call this as a burnout. That actually done in order to actually generate heat into the tires. So to generate heat into the tires, so when the tires actually uh, heat up to a certain temperature only, you will actually have higher traction, right? You will be actually having higher tractions. All right. So that's what actually these guys are doing. So these tires are not the usual road tires. They have something called drag radials. So the tires and everything is different. So that's very complicated. I'm not going to go more towards that. But another application is shown here. So this is a drag racing, and the lower one is actually known as a drifting, right? So drifting is another type of racing. Actually, it's not actually a race. This drifting is actually not considered as racing. It's actually considered as motorsport. So in the drifting, this smoking and wheel spinning is necessary. So in their mind, so this is so in drag race or something, it's actually the winner is decided by who reached the end first, right? Any other race. But in the drifting, it's not like that. It's actually depends on the judges. There will be judges, and there will be some road course, and how the driver is actually navigating the vehicle to that road course is how the marks are given. In that case, in order to keep the vehicle sideways, so we call this as a slipping, right? So this actually known as vehicle is moving towards the yaw, right? This is actually yawing. So the vehicle is moving in a sideways. So in order to keep the vehicle sideways, the wheel slipping is necessary in this case. So that's why it's actually slipping. So before someone asks, so if it is not, I actually explained these two before someone asks. Someone might actually ask if it is not efficient, why these guys are doing it. So that's the reason. So next time if you saw someone try to do a wheel spin, you can actually smile at him because it's stupid, kind of. Right. Okay. So next we move into, so now we know the traction. So what is friction, what is traction, what is drivetrain, right? So next we move into this, how this traction is actually reached up to, how to actually send the power up to the wheels in order to generate necessary traction for movement. Okay. So when it comes to here, we come up to the transmission. So I don't know whether you guys know it or not. The almost every vehicle that we drive, the internal combustion engine vehicles actually have something called a transmission, right? Something called a transmission or a gearbox, right? But in the EVs or electric vehicles, that's not there. Do anyone know why is that? Can anyone answer me why electric vehicles do not need a gearbox or transmission? Sashan, 72. Okay, no answer. 93. Yes, why is that?
I think electrical vehicles don't need to pass the transmission because the wheel will work by using the electrical.
No, I didn't hear you. Can you repeat it again? Can you repeat? You are not clear enough. That's the only problem I have. Can you say it again one time? I'll try to.
In electrical vehicle, don't need to passing the transmission to the vehicle, to the wheel, because wheel is working by using the electrical.
No, that's not the answer. Anyone else would like to try? Sandeep 001. Zero 001. This is Sandeep, right? Go for number one more student. Because yes, 15. This is 15 answered because electric car doesn't need a clutch and it doesn't need a gearbox to change speeds. Yes, halfway it's correct. It does not need to change the speeds. Why it does not need to change the speed? Still, vehicle has to change the speed, right? In the engine also it can change the speed, but still it's need a gearbox. Motor speed changes speed. Yes, but
so I think there is a smart device selector that's get the instruction from the all the like the sensors part. Get the instruction from that one, and according to the instruction, it increase the engine speed and the vehicle speed.
Engine in the terms of motor, right?
Yes, sir. Motor.
Okay, so I will explain how electric vehicle works later on. I just needed to check whether you guys have any idea. Your answer is halfway correct, actually. Halfway correct, but the point is missing. What I'm asking is actually related to something to do with this tractive force and traction and everything. So that's the difference. So who else? Senaviratna. Okay. Senaviratna. Yes, 75. Would you like to try? Sabesh, 68. 73. Senadira, right? Would you like to try at least? Okay, no answer. Let me, yes, halfway you are actually correct. The speed is one of the reasons, but the reason for changing the speeds in a normal or a normal engine sort of vehicle in a normal vehicle is actually somewhat different from the reason you are actually thinking. What you think is the speed, right? But that's not the only reason, right? So you remember that I told you the traction, right? So traction means tractive effort. So if we consider the tractive effort the vehicle have to put on in order for the vehicle to move, right? And if we try to draw it as a graph, right? If we try to draw it as a graph, right? The graph will come like this. Right? So, so graph, the speed is this side and the tractive effort, torque, or whatever it is on this side, right? So that graph actually comes like this. Okay, so at the beginning, in order for the at slow, that means 0 kmph, in order for vehicle to move first, you need to apply more tractive force, right? But when you increase the speed little by little, when you increase the speed, the tractive effort you need to actually put on the ground is actually, or the applied force has to actually be reduced. So if I may, so imagine you are trying to push a desk. So this is you, you are trying to push a desk. So at the beginning, right? At the beginning, you have to add lot of force just to make it move, right? To start the movement. Once the movement start, right? That once you start the movement, the force you actually have to put in order to keep the desk moving is actually less, right? When you so in this case you have to understand it's just a surface, right? It's a flat surface, you are moving to a flat surface, but in this case it's actually rotating, the wheel is actually rotating, so the inertia, the weight of the component is also there, so that's also actually assisting with movement, right? So as a result of that, this sort of graph is actually coming up. So in the engine, if we come back to the engines, right? Engines actually engines could not actually deliver this sort of torque curve, right? The tractive effort, as I told you, it comes from the torque. So that torque curve is somewhat different from this angle. So that's why we actually use a gearbox. I'll come back to this one again. But before that, if we go to an electric motor, how its traction is actually delivered, tractive or the torque is actually delivered, it looks like this, right? It looks like this. So speed is like this, and tractive force is like this. So it's create the maximum torque at lowest RPM, right? So this graph is very much similar to this one. So there's a small gap here. Other than that, it's actually the same. So as a result of that, it actually does not need a gearbox. Without a gearbox also, without transmission, without a transmission, it can actually operate. Also, as a result of this very high torque, even at 0 RPM, right? Even at 0 RPM or 0 speed, the electric motors can generate a very high torque, right? It's generate the highest torque. That highest tractive effort will be put on the ground at the 0 RPM. So just beginning this movement means you have the highest torque in this case of a vehicle. So as a result of that, right, electric vehicles can accelerate very fast. I didn't say they are fast. I said accelerate fast. So that means they can pick up the speed very fast. So that's why EVs are known to be faster than a normal internal combustion engines. Usually say electric vehicles are faster. It's actually not faster. The correct term is electric vehicles are quick. So they can quickly take off from the start. But in the internal combustion engine, it takes some time to generate the movement and everything. It will take some time. But if we consider the overall top speed wise, both are going to be at the same area. Probably internal combustion engine may be able to go faster in most cases at the moment. Most probably internal combustion engine may be able to go faster given that you have lengthier or longer track. So if you have enough long enough track, internal combustion engines can go faster with the distance. The reason being, when the battery when the battery depleting, the amount of energy it can actually deliver into motors will be reduced. As a result of that, its performance actually reduces with the speed little by little. But in the internal combustion engine, it does not have any problem like that. When it's actually accelerating, what actually happens is it's actually take more fuel. As a result of that, it's actually losing the weight. It's just going to be faster at the end somehow, right? So that's what actually the reason is. So as I told you earlier, if we come back to the same thing, right? So in the engine, so I told you the force we need is something like this, right? Something like this, right? So here you can see there's a gap, right? The gap is here in order to mention the clutch slip. So even though we release the clutch, it won't engage as soon as we release the clutch. First it actually sleeps and generate heat, and then only it's actually once it comes to the temperature, only it will actually absorb, still actually stick. So to avoid that, right? There are different ways to avoid that, which we will discuss during the clutch. So anyways, that's why we actually have this gap over here, right? Anyways, so the torque curve of a normal internal combustion engine is very much similar to this, right? Torque curve is somewhat like this. Power curve as similar to the one shown in this red color, right? So the torque is what actually engine delivers. Then we convert the torque into power using a very simple equation. So power is actually a function of torque, right? Power in the engine is a function of torque, right? So this torque actually move us forward, right? That moves us or push us forward. So this torque, this graph and this red color graph from the bottom one is not matching. So what we do is we use this transmission, right? We use this transmission of an normal vehicle to match this torque curve, right? We send it through a set of gears. We send it through a set of gears. So the gears have an ability similar to a transformer. In the transformer, if you properly design the transformer, you can actually give a low current and high voltage. In the outside, the other side or the primary side, if you give a low current, high voltage, right? In the secondary side, you get a high current, low voltage. Same effect can be achieved in the transmission, right? So by doing so, this graph is moved, right? This graph is actually moved up and down, right? Up and down. This torque graph is moved up and down, and parts of it is actually used to match the graph of the necessary, the graph that the ideal graph that we need for a vehicle to actually drive on, right? So this torque curve, if we have this sort of steps, if we change these steps like that, right? Then by matching, if we match these, right? If we match these, right? Then we have a similar curve. This is like exaggerated view, but a similar curve is there. So that's why the transmission is used. So the transmission is actually used to actually get generate the tractive effort necessary for the vehicle to move. So you can't just say speed changes. As a result of that, speed changes, right? As a result of that, speed changes. By matching the speed of the transmission and the engine, only we can actually achieve the best. By matching those two, then we actually change the speed, right? Then only we change the speed. We just not only gearbox is used to change the speed. We use the engine and gearbox to change the speed. As a result of these torque changes, we actually have the speed change, right? We actually have the speed changes. So these gaps, so there are gaps. So in this graph, if you saw here, there are some gaps, right? So these gaps can be actually filled. These gaps can be actually filled. So in order to fill these gaps, you need to have more gears. So if we add another gear between 1 and 2, you can add by adding someone send them. How does motor torque control? Yes, that's a different question. I'll answer later. Yes, so by changing, if we can add if we add a graph like this, sorry, another gear here, right? Another gear here in between the first and second, the gap will be actually reduced. Same way you can add more gears. So if we add infinite number of gears, if we can, right? If we can theoretically or practically add infinite number of gears, right? Then we can actually exactly match this curve, right? This curve. Yes, to answer your question, who asked this? 008 Mohammed. So Mohammed, that's actually the problem here. Let me come back to this graph again. So the reason for engines to deliver torque curve similar to this blue color line and the electric motors to deliver a torque curve similar to this red color line and the second graph is how but that's mainly because how they are actually designing and how they are operate. So the internal combustion engines actually use this crank slider mechanism, right? It's actually use a crank slider mechanism. So because of that, there's not only one force actually activity, right? There are mainly two forces activity. We call them as primary forces and secondary forces. This is very complicated, right? So as a result of these primary and secondary forces, only we get this particular torque curve, right? This is an inherent problem with the internal combustion engine, how they are designed. So we do not actually generate torque curve just by, so we don't actually generate this torque by rotating something. We actually generate this torque by moving some components up and down, right? Then we convert it into a rotational movement. So as a result of that, this odd movement actually cause for this torque curve to come something like this, right? So this is very complicated thing in the engines. But in the electric motor, we don't actually have to control the torque, right? There's no need to control the torque. We just have to actually control the speed. So from the design itself, right? From the design itself, it's actually generate this sort of torque because it's actually rotating item, right? It's rotating item at the beginning of the rotation, right? At the beginning of the rotation, it has the highest energy in it, right? Highest energy in it. As a result of that, it actually turn this rotate this heavy components is suddenly start to rotate. So that actually generate this torque, right? That torque is a result of how it's operate, how it designed, made, and operate, right? Same thing for the engines. So that's why we actually have to use the gearbox, and we do not actually control the torque in a normal electric vehicle. But assuming, right? Assuming, so if we come back to the traction or tractive force sort of scenario, assume that the maximum tractive effort or tractive force that the road can actually withstand is 100 newtons, right? 100 newtons. So electric motor, when at the beginning of that, at the beginning of its rotation, so once we apply the electricity, assume that it's actually generating 200 newtons of tractive effort on the wheels, right? In such case, the vehicle will not be able to move because that too much tractive effort means we are going to lose the, we are going to go over the static friction, area, right? So then we don't have any traction afterward. So as a result of that, vehicle will not move, the wheels will start to spin, right? In such case, there are two methods we can actually use to control the traction, torque in the electric motor, right? Number one method is controlling the speed using a gear, right? Step down gear. That means if we have not a transmission, just one set of gears, there's no gear changing mechanism, just one set of gears, right? One set of gears to increase, reduce the speed or increase the speed and reduce the torque as a result, right? As a result of that, the torque will be actually dropped down, right? And the second option is we can assuming this is let's assume this is a DC motor, right? This is a DC motor. We can use a very simple method such as PWM. PWM is applying and turning turning on and off the motor, right, in time intervals in order to provide the power and turn it off, power and turn it off. By doing so, we can actually control the torque in a level that we need, right? That's actually done by a control module inside the electric motors, right? So we just apply the accelerator, but the system itself actually controls that, right? System actually itself controls that. Assuming it's a AC motor, then we can actually control the frequency of electricity is actually provided into the motor by changing the frequency. Again, we can change the speed. By changing the speed, we can control the torque, right? All these, both of these methods can be used. What I'm trying to say here is electric motor is from the design itself. The electric motors does not actually need a gearbox, right? It does not need a gearbox, but it does not mean that you can't use it. You can actually use it, right? So controlling an electric motor, the torque control of an electric motor is quite difficult and quite complicated, right? Quite complicated, similar to the internal combustion engine. I hope you got an clear enough answer. Okay, so we'll come back to this. So by changing the speed in this case, also we actually change the torque by reducing. So during this, so because we have different gears now, even though vehicle's torque is the same, at engine is operating in the same RPM range, for 5 gears, they are operating the maximum speeds they can actually reach is actually different. So in this case, so this is actually for Subaru Impreza or something. Yes, Subaru Impreza turbo diesel. So top speed can be achieved as 6 gear, right? 6 gear. But in the 6 gear, the tractive effort it actually delivers is low, right? But in the first gear, it's actually delivers higher tractive effort, so it can actually take more load. So that's why when you increase the load in a vehicle, you actually have to come to a first or second or something like a lower gear, right? Lower gear. Hope you got up to there. Okay, so we now we come back to the transmission again. So transmission actually classified. We can classify the transmission into different. 2 methods are there, right? 2 methods are there. So one is transmission. So one thing you have to understand is classification of the transmission is very difficult nowadays, especially nowadays, because transmissions are very complicated. By design, they are actually very complicated. The automatic and manual transmissions are now almost interchanged. So some manual transmissions can work as automatic transmission, and some automatic transmissions can actually work as a manual transmission. Nevertheless, we'll try to like do a small classification. So this is one classification that we can do. So transmission, basically we have manual and automatic, right? So in the manual transmission, we have H pattern manual, and we have another types of manuals are there, but then we have the automated manual transmission. So this automated manual transmission, even though it's a manual transmission, it's exact operation wise, it's actually like a automatic transmission. Next, we have the planetary gear type transmission, planetary gear type automatic transmissions, and continuous variable transmission, also known as CVT transmissions, right? So both of these transmissions also can operate similar to a manual transmission nowadays, thanks to the computer control system. That's again comes back to the powertrain control module. Anyway, so this is somewhat clear and simple classifications, but you can just remember this, how these are actually classified. So automated manual transmission, so AMT, as even though it's operate as automatic transmission, it's actually from the underneath the construction, right? It's actually a manual transmission. Similarly, even though the Striptronics and Striptronic and what the Hyper CVT and all these gearboxes types are there, even though they operate as a manual transmission, they are actually automatic transmissions, right? Just something to remember. So now we come back to this transmission and gearbox problem, right? So I teach this every time, even your seniors, I recently also discussed this part. So transmission and gearbox is 2 different things, right? So usually we call this whole section as the gearbox. That's wrong. The gearbox part is only the middle section, right? So this section This is the gearbox actually, right? This is the gearbox. This is called as the bell housing, right? So engine actually comes and connect over here. Engine comes and connect here, right? So next to the engine, we actually have the bell housing. Inside the bell housing, we have the flywheel, the clutch pack or clutch, or in the automatic gearboxes, we have something called a torque converter, right? We have those components in here, right? Then the gear changing components, the box of gears, right? Box of gears actually situated in here, right? This middle part, right? The gear change mechanisms and all these parts are actually housed in here. So this is the gearbox, right? This is the gearbox. Behind that, we have something called extension house, right? It could be extension housing, it could be a transfer case, it could be the anything other than that. If you have something like a winch or something, mechanical driven winch or something, all these components actually comes and connected to here, right? So gearboxes are actually designed in this way for manufacturing easy, so make the manufacturing easy and cost effective. So by manufacturing in like 3 different sections, the same gearbox, right? Same gearbox can be adapted for few different engines and few different drivetrains, right? For example, right? So assume this gearbox. So let's say there are 2 engines, A type engine and B type engine, right? So in the A type engine, the starter motor is connected to the left of the engine, and the B type engine, the starter motor is connected from the right side of the engine. So if we suppose if we have two different engines, if we try to design 2 different gearboxes, then we have to design the whole gearbox, right? Whole transmission, right? So that's costly. So instead of doing that, you have the transmission in 3 pieces, gearbox only in one section. The bell housing is a separate section, so you can actually swap the transmission, sorry, bell housing to match with each type of gearbox, each type of engine, right? Each type of engine. So that actually reduce the manufacturing cost and complexities in the manufacturing, and additionally it's actually provide easy maintenance, because we can just remove from here, and we can actually open the transmission or the gearbox from this side over here, right? And we have the gearbox. If we go another scenario is behind. So usually in this extension housing, it's actually houses the transmission or the changing mechanisms, if there's any gear changing mechanisms, and wheel speed sensor, right? So the vehicle speed is actually measured from the transmission, not from the wheels, right? It's actually measured from the transmission. So that part is actually housed inside of this components here called as extension house, right? So assume that this particular gearbox is to be used in an all-wheel drive layer or a four-wheel drive layer. So 4-wheel drive means, in order for selecting front wheels and rear wheels, or 4-wheel drive or rear wheel drive, in addition to the gears, we need to have some component called transmission, right? So transfer case. So transfer case, instead of adding the transfer case separately, we can now directly bolt it here. So we don't actually have to cast this whole component separately. You can just add the transfer case at the end of the gearbox over here, right? So for the same gearbox can be adapted in different scenarios, different engines, without making or doing a lot of changes. So that's why it's actually comes like this. So again, we have bell housing, gearbox, and extension housing, right? So this part we will not be discussing that much. From here onwards, we will be discussing about this middle part, which is very much important for us. And when we discuss about the clutch, we'll be coming back to the clutch, right? We'll be coming back to the clutch. So extension housing, as I told you, there's not much to see. Yeah, one more thing, reverse switch. So when we change the reverse, In order to select the reverse, usually the switch, that the electronic signal signaling switch, it's actually have electric switch, small switch that's usually housed in the extension housing, so for easy maintenance. Okay, so we'll go ahead and discuss about the gearbox. So principle of the gearbox. So the principle of the gearbox, we'll be doing some calculations based on that once we completely finish this session. After discussing the wheels, the whole section, that means the drivetrain, whole drivetrain, we can actually do small calculations about the vehicle top speed and power necessary, everything we can actually decide, right? Do some calculation related to the engines. So basically, right, there's a very simple simple relationship between these gear wheels, right? It's related to the diameter of the wheels or the number of the teeth. So number of the teeth and the diameter of the wheels are actually same. So if you have when a higher number of teeth, the diameter will be higher. If you have low number of teeth, the diameter of the wheel will be lower, right? So this actually related to this omega 1 and omega 2, that means rotational speed, right? Rotational speed. So basically what it means is omega 1 is equal to omega 2 equals omega 1 over omega 2 omega 1 over omega 2, right? That means the rotational speed is equal to minus n1 over n2. So this n1 and n2 means the number of gears, right? Number of gears. Okay. So this n means the rotational speed, right? Rotational speed. I have another, I'm planning to do another tutorial. During that tutorial, I'll explain again about this section. So this minus actually comes from the direction. So assume that this gear wheel is rotating that way. As a result of that, small will be rotating this way, right? So not the same direction. So, and this, so I forgot to put what is T1 and T2. T1 and T2 are the torque values. So this N1 over N2 is equal to T2 over T1. That means if we have a lower, if we have lower torque in this larger wheel, we have a higher torque in the smaller wheel, right? So that's what actually means. So that's how we actually move that graph. That's how we actually move that graph, that torque curve, something like this. By changing these gears, right? Or combining these gear teeth numbers, gear wheels, we can actually move the curve upwards or downwards, right? By and matching the locations to the graph we actually need, right? We actually need. Hope you get that at least somewhat. Okay, so each different engines have so gearbox actually have something called gear ratio. Gear ratio means the this value, this one over here. This is the ratio, right? This is the ratio of a gearbox. So these gear ratios are how we actually measure the speed of a vehicle. You remember this graph over here. So this graph actually generated from the gear ratio. So the same graph we can actually draw for any vehicle as long as we know the gear ratios, right? In the first gear, the gear ratio is 3.16 to 1. So that means the engine, when engine is actually rotating 3.166 turns, the transmission output shaft will only rotate 1 turn, right? Similarly, for all gear wheels, all gears, it's actually mentioned here. So whether it's automatic or manual, this is actually the same. So output, the gearbox output of the at 3000 rpm is also actually given here. So in order to achieve this, we actually use this gear wheel. So gear wheels also for any gearboxes, there are two types of gear wheels we can very easily use. That's depending on the gear, how the gears are actually, how the gears are. So transmissions or the gearboxes actually use two types of gears are mostly used in the automobile applications. One is actually known as spur gears, the other one is actually known as helical gears, right? So spur gears are actually parallel to the axis of the shaft, right? Axis of the shaft that the gear wheel is on, right? So these type of gear wheels are simple to manufacture, less costly and all, but not in use most of the time. The reason being, we have a better type of gears. This is actually known as helical gears. So helical gears, as you can see over here, the gear tooths are actually angled, sort of like a curved. So as a result of that, even though this is actually contacting one point of here, these type of gears actually contact patch. It's not only one teeth is being connected, it's all the time two or more teeth will be in contact. So over here one wheel and below another teeth is in contact. And since the since these helical gears are cut in an angle, the thickness of the gear wheels will be actually reduced, right? Will be reduced. So more and more vehicles are nowadays using these. Earlier days, when the vehicles are using these sliding mesh gearboxes, these were very popular. These were very popular, but at the moment, these are not that much important, right? Not that much important. But nowadays, since we have constant mesh gearboxes where the gear wheels will not be meshing and disengaging and engaging, these sort of wheels can be used, and these are quieter and they can transmit more power and more force towards them. So as a result of these are more useful, but at the same time these are actually bit heavier. So uh, but still these type of gears are used in gearboxes such as these race car gearboxes, because by changing the material, expensive materials can be used, and still this gear system can be used. One main disadvantage of these type of gears are these are very noisy. So when the engine is rotating at a higher rpms, this is very difficult to use in a normal vehicle, but in a racing application it's not an undesirable thing. But main problem with these helical gears are they are not capable of taking the axial load, that means load acting on this direction. So in a normal situation it's not a big issue, but in situations like racing where you will be changing the gears very hard gear changes are happening, at such case the axial forces are higher. So having this spur gears is very beneficial in such cases, so they use spur gears. Okay, so we'll go to the manual transmission. So manual transmission, as we know, nowadays becoming a scale. So more and more people would like to actually drive the automatic gearboxes, and how much we means nowadays there are even license are allowing only for automatic gearboxes, right? So that because of that, right, because of that the demand is higher for automatic gearboxes. So manual transmission, so manual gearboxes are very low in production now. As a result of that, manual gearbox vehicles are getting very popular, very expensive, high expensive to use, maintain and all. But still it's the driver, since the driver can select the speed and all this, still the vehicles drivers seems to prefer it, especially these enthusiastic drivers and the people who like take charge during the driving still prefer the manual transmission. But automated manuals are now becoming a norm in the most cases. Unless the driver needs to generate some skills or some things, the manuals are becoming a thing of the past. Anyway, uh, manual transmission, as I know that we have already discussed during the practicals also, we have sliding mesh gearbox, constant mesh, and Cinco mesh gearbox. So the image shown here, right? Image shown here is actually known as a gated transmission. So this sort of arrangement there, you can see it's like a gate over here, right? So this sort of gearbox is actually known as a gated transmission, which are very you can only see these sort of transmission in high end sports cars, right? High end sports cars, you need to a little bit tough to change the gears, but you have more feeling when you change the gear. Okay, just give me 1 second. 1 second. Okay, so we have sliding mesh, constant mesh, and Cinco mesh gearboxes. You know how the sliding. I don't have to go through these things again and again. If you have any questions, please ask. But I'll just go through them very fast. So in the sliding mesh gearboxes, the gears are actually sliding back and forth. So gears are permanently mounted on the output shaft itself, and so by when we change the gears itself actually moving or slides left and right and meshes with another set of gears. So constant mesh gearboxes came next. In the constant mesh gearboxes, you know that engine shaft or the input shaft is comes here and it's transferred to a lay shaft or secondary shaft, which is then paired with the uh, output shaft gears. But output shaft, the gears are not directly connected to the output shaft. Instead of, they are running on bearings, they are actually running on bearings. So even though the gears are constantly meshed, the power is not transmitted to the gear main shaft itself. Instead of that, these sort of gears actually use something called door clutches. So in the door clutch, there's a sliding sort of mechanism which has teeth which will be engaged with each set of gears in order to actually change the gears. In the reverse gear changing, still they actually had to use a separate gear as shown here, because in order to actually change the direction. So Cinco mesh gearboxes came next because of these door clutch gearboxes were difficult to operate, especially when changing the gears. So the Cinco mesh unit actually came. So Cinco mesh unit is actually a components that replaces just all the door clutch. The advantage of this Cinco mesh unit is it's actually has some design that has a method to synchronize the speed of the gear wheel itself and engage. So that's why it's actually Cinco mesh gearbox. So the synchronizer is the added component in this. So this is actually comes under the constant mesh gearbox types. So this is a constant mesh gearbox type. So this is the Cinco Cinco mesh unit, right? This is the Cinco mesh unit. So the synchronization unit. So what actually happens is, because of this angle, so you can see this sort of like a cone sort of angle, right? So when we try to move the Cinco mesh unit towards the gear wheel, right? When we are trying to move it towards the gear wheel, this what actually happens is this Cinco mesh unit and this cone, right? These two cones, these by rubbing against these surfaces, they automatically synchronize the speed, right? Synchronize the speed and come up to a relatively same speed, and these teeth will go into the these grooves over here, right? These grooves over here, then the gear is actually engaged. So that's what actually happens in these gears, and that's what actually happens in these gears. This system is very simple, but everything actually depends on this the quality of these components. So this since these two are rubbing against each other when during the operation, this actually made of brass, so it's actually known as a brass cone. So when the gearboxes are getting older, this part actually started to wear out very easily. So whatever this gearbox type is, the gear selector mechanism or gear changing mechanisms also, there are few gear changing mechanisms. So if we start from the first one, we have the H pattern. H pattern is this one over here. So this is H pattern. You can see it looks like a H, right? That's actually the H pattern. So I actually forgot to put a picture here. It's okay. Right. So H pattern gears are changed by navigating the gear selection shifter in a similar pattern to H, right? One advantage is you can actually change the gear from first to third or first to fifth or whatever the gear you name, right? One advantage. The same gearbox, the gearbox type is not changed, but the gear changing mechanism or the selector mechanism is different. The selector mechanism is also available, sold as sequential gearbox, right? The same gearboxes are available in motorbikes. Motorbikes actually have the sequential gearbox. So in the motorbikes, if you have seen a motorbike, when we actually rotate, when we press the pedal front and back, it's actually rotating a shaft. That shaft, the rotation of that shaft provides a similar movement to a H pattern, right? Similar pattern movement to the H pattern. So that's how it's actually changed the gear. Yeah. So one advantage of this sort of gear changing is it's actually very fast, because here we actually have to navigate and put, but in the sequential gear changing, we just have to pull or push to one way. As a result of that, gears will automatically change. One disadvantage is, in order to do so, you actually have to add a bit more weight, right? Bit more force has to be applied. So this system is not much being used in the vehicles, but like four-wheel vehicles, only motorbikes and three-wheelers use this. H pattern gearbox is the very popular one. But sequential gearbox is sequential gearboxes are very popular in off-road vehicles. Sorry, not off-road, racing vehicles, because this actually provide the gears to be changed very fast, right? Very fast. The gear changing time is very important in such cases. So next we have the automatic manual transmission. So automatic manual transmission is a manual transmission completely automated, right? Completely automated. That includes the clutch, gear changing and everything. So in this system, it's actually replaced, the clutch is replaced by, clutch mechanism is replaced by a electronic actuator that pressurize the hydraulic fluid and move the clutch lever. Similarly for changing the gears also, right? And the shifting is actually controlled by the powertrain control module again, right? The powertrain control module is actually controlling the whole gear changing, and the gear changing is actually not directly based on the gear necessary, and it's actually depends on the output and whether you have traction control or something switched on. Everything is actually considered in this method. This system is actually first introduced by these Formula One cars. Formula One cars actually started using this system in, I think, 80s or something. If I'm correct, they started using these in 80s, like this Ferrari, yes, Ferrari company. I think you started using these gearboxes. So they have the pedals. Usually you call them as pedal shifters, right? Pedal shifter vehicles. So now it's becoming a very common thing. The same gearbox is similar pattern gear changing system is available. So Suzuki Celerio become one very popular gear type, and Honda Fit the vessel. These two also utilize the same gear system for actually operating this hybrid system. So in order to use the hybrid system, vessel and vehicles like Honda vehicles use the same gear system, but for use the hybrid vehicles, right? Mostly for hybrid vehicles. So in the Formula One, in order to, reason for applying this system is to actually change gear changing speed, and they don't have much space in the cabin itself. You just in a Formula One car, you just actually, I mean, you don't even have a seat. You just sit on the floor of the car, and then you will be like packed. Like bolted into the vehicle itself. So space is limited. So they developed this system to change the gears faster. So the same technology now came up to the vehicle. So the fun fact is that Suzuki Celerio, right? Suzuki Celerio is actually using a gearbox or the gear selector mechanism manufactured by a company called Magneti Marelli, right? The same guys actually manufactured the Formula One gearboxes as well. Okay. So selector mechanism, the usual selector mechanism, the H pattern selector mechanism is somewhat looks like this. I'm not exactly sure whether you are, you can understand this image. So let me try to explain it as much as possible. So over here we have the gear lever, right? Gear lever is suspended on a ball, right? Suspended on a ball on the gear box itself or the transmission itself. Then we can actually move it forward, backward, left and right? So if you look at from the top of this, we have something looks like this. So if I draw where our gear selector mechanism or gear selector, gear selector is somewhere over here, right? So I can move it left, sorry, in this case up, right, up and down, left and right. So for example, if I move this gear lever downwards, right, down and up, right, down and up, right, down and up means what actually happens is the shaft, since this is suspended in a way like this, right, the bottom part of the gear shifter, gear lever is moving the other direction, right, opposite direction. So as a result of this, so if I move it left, the bottom part is actually moving to the right. Sorry, not our left. If I move the gear shifter, lever down, the bottom part of the gear lever moves up. Then second, if I move the gear lever forward, Oh, no, not forward. Now it's right. So left leg. The gear lever is, the bottom part of the lever is moving right. So that means if I do left, down and up, as a result of that, gear shifter, the bottom part of the shifter is actually moving up and left, so right, up and right. Then when it actually what actually happens is this bottom ball actually it moves from the center point to uh, the, the shaft on the top and push it backward. When it's pushed backward, gear is actually changed to gear number 1, right? So in order to do that, these shafts are actually connected to these forks, right? These forks over here, right? These shafts are actually connected to the forks here. So these forks, let me try to show you the forks again. Let me see the forks here now. Okay, so the forks comes and goes around the door clutches or Cinco mesh unit. So Cinco mesh unit is moving left and right. Finally, moving the left and right. Then, in order to keep the gears locked in place, not to bring them back, spring-loaded ball mechanism is used for each shaft, right? Each shaft. So this is actually known as a pin. So this pin is kept keep the gears from popping back or coming out of the gear, right? So this actually shows how the gears are actually locked. So you can see this spring is actually locked. So that spring keeps the gears moving back and forth, or movement of the gears without the selection. So once everything is actually connected, so these are the forks, right? So these are the selector shafts, right? So these are the selector shafts. So now again, I need to come back to this one. This is actually a sequential transmission gearbox. So because this is a sequential transmission, I don't know whether you can see it here. There are grooves like this, right? Grooves like this, right? These grooves actually move. So do you know, can you see this? There's like a small pin connected here and here and another pin over here, right? So what actually happens is when you push the lever or pull the lever, this rotate one way, let's say clockwise. When you push the lever, right, this shaft moves other way around, right? So that actually changes the gears. So this is sequential gearbox. This is the H pattern gearbox. So the same gearbox, same H pattern. So everything else is same except for this part over here, right? This part is actually completely replaced by this shaft and this push-pull mechanism here, right? So I have added some links over here. Please go ahead and watch them. I don't, it's very hard to actually explain this without a gearbox. I actually have a gearbox, so I'll try to do a similar session to the previous one we did, but unfortunately this lockdown is going to be a problem because the transmission system or the gearbox is, or the transmission is not at my home, it's in shop, so I have to go and bring it home. So if I could go, I'll bring it and I will explain it to you guys. Anyways, so next we comes to the lubrication part. Late. So lubrication of the gearbox is very important thing, right? Lubrication of the gearbox is also very important. So as you saw earlier, the gear wheels are ready. So these are actually Yes, sorry, these are actually metal on metal, right? So to reduce the friction, we need to actually add lubrication. So gear wheels, gearboxes actually, gearbox sound like this actually use the manual transmission, right? Manual transmission actually use something we called as a splash type lubrication system. So they don't have a pump or something supplying the lubrication unless it's necessary. I'll come back to the unless necessary part again. But it's when the oil is actually filled up to a level similar to the one shown here, when the gears are actually operating, as a result of that, lubricants will be actually splashed around the gearbox. So almost all the components are going to be automatically lubricated, right? Automatically lubricated. But there are some instances, some parts will not be lubricated. For example, if this extension housing is too high, or if these selector mechanisms are not properly lubricated, in such cases, small sort of a mechanical pump will be actually delivering the lubricant into these locations. But it's not a must, right? It's not a must because there are other solutions for this. For example, the splash can be used to lubricate this extension housing and the output shaft. And for this section over here, not much of a lubrication is necessary, as it can use the Teflon sort of hard plastic materials with along with the grease to actually lubricate this part. So it's not a big issue, lubrication these two, but lubrication of the rest of the components is the important one. So lubrication oil wise, usually it's around SA 80 or higher grade. So thick oil has to be used compared to the engine. And since these lubricants are not exposed to high heat cycle, so that means it's not heat temperature is not reaching over like 100 degrees, not even 100 degrees. So there's no combustion happening here. So it's not exposed to any heat cycles. So as a result of that, this lubricant, the gearbox, the manual transmission lubricant, can last long as around 100,000 kilometers, right? 100,000 kilometers, so around 5 years, right? So afterwards, it actually has to be actually replaced, right? Around 80,000 to 100,000 kilometers, the lubricant has to be replaced properly for gearboxes to work. So next I have the transmission, automatic transmission, but this will take another around the same time again. So I think I will stop the class today from here, right? We will pick up from this point next day, okay? Because I didn't expect it to go this much time. I expected to be finished within like 1 hour, the previous section, but it took 2 hours. So we'll come back to this section next day. Before I stop, I forgot to say one thing. So again here, so this is the reverse switch. So in order to identify when the gear is changed to reverse, this is the switch. So this actually operates the rear lights. So we'll come to the session again. So I will start with the automatic gearbox next time. So I will explain how the automatic transmission works. So it's quite complicated. Yeah, so I was actually planning to finish up to here, but unfortunately I will not be able to do it. I will be only finished over here. So the next part, that means transaxle flywheel and automatic transmission along with the clutch and all these sections we'll be discussing the next class. The plan is to next class. I was actually planning for 2 sessions, but it seems like I'll be going for 3 sessions.